All right, so today is the beginning of our 1.1 D notes, understanding error and defining residuals, okay? We're going to talk about what a residual plot is, what it means, and go from there. Make sure if you need to turn your desk, adjust yourself. By all means, please do whatever you need to do to make sure that you're in the most ideal position for you to learn, okay? But this is what we're at. All right, so to get started, we're going to write that what does residual mean? Okay, your residual means in the first blank, actual y minus expected y. So on your handy dandy little booklet you just made, you're gonna write actual y minus your expected y. Do we all see the blank? All right, so if you look right here, we have a scatter plot. On this scatter plot, that is not my laser. On the scatter plot, we have our the diamonds. Those are your original scatter points, your points. My blue, that is my regression line, and the blue dots are your regression points. Okay. What was the original? Actual y minus expected y. All right, the red line segments, that's the distance between your residual point, your regression point, and your scatter plot. That distance is called the residual. Okay, that distance is called the residual. So the lengths of the red line segments are called our residuals. It's already written there for you. You can circle it, you can star it. I put a little star by it, but that is what those are called. Okay. So what we're doing today is we're going to be calculating that value, that residual value. Okay. We're going to find the difference between the two is our goal and our objective. All right, here we go. So we're going to calculate that. It's not that terrible. Now, why are we calculating that? Well, we're doing this it's one way to determine how well a linear model fits the data set. And that is by squaring the residuals. Okay. So your first blank is squaring the residuals and examine the sum of the squared values. So we're going to square the residuals and examine the sum of the squared values. Okay. Why do you think we would square the residuals? What happens when you square a number? It multiplies by itself and it does what to that number? It gets bigger, but if that number is negative, it turns it into a positive. And that's because a negative times a negative makes a positive. So why do we do that? It's to get rid of the zero, to get rid of the negatives. To eliminate negative values. So we do that to eliminate negative values. We only want to focus on the positive, which is how you should live your life, focusing on the positive. Okay, geometrically, back to geometry mindset. When you talked about squaring a lot in geometry or squared anything, what did it typically refer to? Shapes. And what about the shapes? The dimensions. Using the dimensions to find the what? Fine. The area. Using the dimensions to find the area. So geometrically, do y'all remember saying units squared? That's because we were always finding the area. Okay. And when you found the area, what was the area? Was it positive? Yes, it was always positive. Okay. So we're going to go back to our graph. We're going to talk about what that means. So when I square these values, what I'm doing literally is making a square. And please pretend that these are all perfectly the same size and straightest lines you've ever seen in your life. Exactly. Because, you know, that's what I'm telling you. And that's what I'm marking it as. So when I square it, I'm now creating these squares. And when you're looking at the squares, the goal is to make your squares as small as possible. Looking at our perfectly drawn squares up here, which one has the largest discrepancy? D2, right? That is the one that has the largest area. So that's our point that has the largest difference. Does that make sense? Okay. Is it back to the report? All right. So our goal when you're trying to figure this out is to make your squares as small as possible. Does that make sense? Yeah. Because we want to eliminate as much error as possible. All right. Now, I'm going to show you the full fancy definition here. All right. So this was like just kind of like, okay, let's paraphrase. I'm going to show you the full thing here in a second. So squaring residuals, it ensures that all the resulting values are positive, okay? A lot of times from here on out, though, I will show you this, and I want you to paraphrase. When I tell you to paraphrase, some of y'all literally try to write everything down, okay? Paraphrasing means to put it into words that you feel comfortable with, okay? So do you see how I paraphrase this for you? I said we're eliminating the negatives and focusing on the positives. Isn't that just what that pretty much is saying? Yep, it is, okay? Then when we talk about geometrically, what does it mean? It says we are finding the area of the square. Is that what we talked about? Yes. Finding the area of the square, okay? And then we mentioned how the smaller it is, the closer it is to being the actual. Yep. The bigger it is, the more discrepancy there is, correct? All right, perfect. So we're going to practice finding the residual, okay? Do y'all remember on your Do Now on Friday, we talked about Stella, Jasmine, and Brandy? Yeah? And we had to decide from their three tables in their three equations who had the most accurate or the correct answer. Yes? All right, we're going to talk about there's another way to have analyzed their information, and that's by using your residual. Okay? So using the residual data. We're going to be using our TI-84 graphing calculator to do so. What I need you to do is to make sure you clear your calculator. How do we clear our calculator before we start it? We're going to go second plus 712. Okay, before we do anything, we're going to clear our calculator. Second plus 712. Okay, second plus 712. And then we're going to follow these 6 steps to figure out their residual. Okay, we're going to do 2 methods of finding the residual. First one is going to be graphing and or table method. And then the next one is going to be our stat method. Okay, all the steps are listed out for you. If you're a person who likes to read ahead and work ahead, guess what you can do? Read ahead and work ahead because the steps are pretty much foolproof, okay? So you're going to graph the given equation in y equals. Then we're going to change the window to fit our given information, then graph. We're going to find the expected y values by pressing. You have 2 options. You either can press second trace 1 and find it from the graph, or you can go second window and change from independent to auto, and from auto to ask when you're independent, and then inputting your own table values. We're going to model both. Then you're going to find the difference by pressing second mode and subtracting your y values. So your actual minus your regression, your actual minus your regression. And then you're going to find the residual squared by squaring, and then we're going to total. Okay? All right, here we go. Diving in. I'm going to pull up my handy dandy calculator named Sylvie. Where is Sylvie? Here she is. I'm going to reset her. Second plus 712. Sylvie's been resetted. And I'm going to go through the steps. So step 1 says I'm going to go to y equals. And I'm going to input my given equation. My given equation is 1 and 400 x plus 3 and 4600. I know. Okay, your x is, all right, so I did that. Now, second step says I'm going to change my window to fit my data. Do we see that? Is that what step 2 says? Yeah. Yes, we're going to change our window. To change our window, we literally just are going to press window. We're going to press window, and we're going to match our data to our graph or our given table. So when we look at this table, it tells us we have a x minimum of 0. We have an x max of 200. It tells us that we're counting by what on our, what are we counting by? We're counting by 25s. Okay, and then we're doing the same thing on our Y's. Agreed? 0, 200, and our scale is 25. Do you see what it means? So change your window to fit your data. Good? Questions on step 2? All right. We're going to hit graph. And now I should have created the graph on my thing. Yes? All right. Now we're on to step 3. Step 3, we have 2 options. We're going to do 3A first. 3A, to find our table values. Our expected Y value is what we're trying to find. We can press second, trace, and value, which is 1. And I can type it in. So second, trace 1. And now I can type in 30. And it tells me the value of 30 is 34 and 6600ths. Do we see that? So I can write down 34 and 6600ths. Was that terrible? Second, trace 1. We're following the steps on step 3A. The X what?
Express.
You didn't change that? Yeah. You only changed your min, your max, and your scale. All right. All right. So again, once I have that open, I can now type in 62. 62 is 67. Second, trace 1. Second, trace 1. Okay. How do you feel about 3A? Doable? All right, now we're going to model 3B. So if you're like, oh, this is cool. Well, here's 3B. 3B says you're going to press second table set, and you're going to change your independent from auto to ask. So we changed our independent from auto to ask. And now we're going to go to our table. How do I get to my table? How do we get to our table?
Second graph.
Second graph. To get to our table, we press second graph. Notice that our table is now what? Blank. So that means that you're going to fill in what you want. So I'm going to type in 30. Because we did the second window and we changed our independent from auto to ask. That means you didn't reset your calculator and you left someone else's stuff in there. I will come 124, 130, 151, 185. So notice here, this allows me to find all values at one time. If you are lost and stuck, raise your hand and I will come. Okay, so when you look here, window, you're going to go down to independent. Go to the top bottom, press enter. And now you're going to go to the second graph. And now you can put in your value. If you don't have a Y, you can put the whole stuff in this. Step 1. Got it? All right, I'm going to put that in. Otherwise, I won't be able to put it in. Okay, so now we're going to all right, anyone else?
Damn, like that. 2-1.
All right, I'm gonna write mine down so I can be where you are. And change the brightness a little bit. All right. So after 67 and 9400ths, I have 91 and 8600ths. I have 132 and 4200ths. I have 130. I skipped something. Am I good?
150.5.
I'm on 160. I skipped something. 34, 67, 91, 132.
You have nothing. Except that value at the bottom is.
Oh, I added an extra value. Delete that one. 138 doesn't matter.
I got 160.
Yeah, it's not you, it's me.
You're on.
I'm unpinned. Am I back on? All right, we're just gonna be lazy, 60. And then we're at 195 and 86. All right. Value's good. Step 3, done. Now we're on to step 4. What does step 4 tell us to do? We gotta find the residual. So how do we find the residual?
Actual part is connected.
We're gonna subtract our y's, right? In order to be able to subtract, we need to get back to our calculator page. How do we get back to our calculator page? Second mode. So we're gonna press second mode. And now we're just subtracting our actual minus our expected. Do we understand that? So we're subtracting these values. Pew, 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 pew. And what do they equal? So we have 30 minus 34 and 6600ths. And we get negative 4 and 6600ths. If you want to kill 2 birds with 1 stone, after you find your residual, you can then also just find the square by pressing square. And it will square it for you. And now you have your squared residual, which is 21 and 72. So we're going to do the next one, 65 minus 67 and 94. We get negative 294. We're going to square it. And we end up with 8 and 6400ths. We have 102 minus 91. Hit enter. And we get 10 and 14. We square it. And we have 102 and 82. We have 130 minus 132. We get negative 242. We square it. And we get 5 and 86 because the 6 rounds the 5 up. We have 165 minus 160 and a half. We get 4 and a half. We square it. And we get 20 and 25. We have 190 minus 195 and 86. We get negative 586. We're going to square it. And we get 34 and 34. How do we feel about steps 4 and 5? Easy? Right? No?
Yes.
Okay, good. I was like, is it not? Okay, 4 and 5. Check. All right, 6 is the easiest. What does 6 tell us to do? Add them all up. So we're going to find our residual squared sum, the sum of our squares. And all we're going to do is add up our 6 numbers. So we have 21 and 72 plus 8 and 64 plus 102 and 82 plus 5 and 86 plus 20 and 25 plus 34 and 34. Yes, that's what I got. I got the same thing. And we get 193 and 6300ths. We found the sum of our squares. How do we feel?
How about this for right
Oh, don't ask me right now. Yeah. All right. Yes. Okay, so this is option number 1. Option number 1 works anywhere, anyhow. As long as you have a graphing calculator and you can find your y's, you can always subtract and square, correct? I can use any calculator that I can plug in and calculate. Does that make sense? Yes? Any scientific calculator, and this is going to be done. All right, now we're going to talk about option 2. Option 2 is specifically for the TI-84. Okay, option 2 is useful when you have a really large set of data. Does that make sense? If I have a really large set of data, do I want to have to find the difference and square it over and over and over? No, or do I want the calculator to automatically do it for me? I want the calculator to automatically do as much as possible for me. Does that make sense? Okay, that is what option 2 is showing us. Okay, again, if you are a person who likes to read ahead and try ahead, the steps are completely listed out. If you're a person who needs to follow along, we're going to go through these 5 steps together. Okay, all right, so here are our 5 steps that we're going to follow. Before I get started, I'm going to go ahead and clear my calculator just because I like to start off with a fresh calculator. And how do I clear my calculator again?
2 plus 7.
Second plus 712, right? Second plus 712 is going to clear my handy dandy calculator. Okay, so I'm going to open Sylvie back up. Sylvie's going to get cleared. Second plus 712. And now Sylvie's going to get ready to follow these steps. So step 1 says that we're going to stat 1 edit, and we're going to put in our information. So we're using Jasmine's information now, and we're going to follow the steps. So we're going to stat 1 edit. And in our L1, we're putting in our X value. So this is our L1. And in our L2, we're putting in our Y values. So I have 30, 62, 85, 124, 151, 185. Gonna arrow over. I have 30, 65, 102, 130, 165, and 190.
Where's the end?
Stat 1.
That one.
It says edit.
Yeah.
What do you mean? And then it says 1 edit.
You're already in the egg. You're now filling it in.
You're now filling it in. All right. Okay, so now it says that we're going to go over to L3. When it says arrow to L3, you want to make sure you're on L3. You want L3 to be bolded. Okay, you're going to press enter, and we're going to input our equation. Okay, but instead of X, we're putting in L1 because L1 has all of our X values. Okay, so we're writing 1 and 09 times. To get your L1, you press second 1 and it will put L1. So we typed in. So we went to L3, press enter so we can input what we wanted to calculate. So we typed in 1.09 times L1, and I'm going to finish inputting the rest. So that's minus 2 and minus 2 and 81 hundredths. I press enter, and guess what it does? It fills it in for me.
I don't know. You're gonna go
Please expect to one.
All right, so the bell's gonna ring on us, but go ahead and write down your values.
Didn't work. I just my whole side of it.
I don't know what you did. I'll have to look. So you should be able to write down your values, and we will pick up from here tomorrow.
I will.